made it cool. All right. How we doing, folks? We're going to learn about velocity today. Let me get this angle right. All right. How we doing? Okay. I haven't posted in a while. I'm sorry. That's my bad. But we need to get caught up on what we were doing. All right? So, picking up where we left off. Speed, okay? We need to talk about something very similar to speed called velocity. All right? How are they different? Good question. Very good question. Speed is like how fast you're going. It's a rate of change, all right? We discussed this. We found this in the lab that it's a rate of change of how much distance we cover per unit time. Velocity is also that, except velocity includes a direction. Now remember, the difference between distance and displacement included direction as well. Whenever we have displacement, we want to know how far are we from where we started, as well as the direction. So if I want to know how to get to Cleveland, I can't just say 10 miles. I got to say, well, 10 miles north or 10 miles east to somewhere, or else that just doesn't make sense. With velocity, you need to know which way you're going to. So in this example that we see here, we've got two cars, and one's going to the right at 25 meters per second. Its velocity is positive 25 meters per second because it's going in this direction. Now, if we want to indicate it going in a different direction, the way we do that is we have a negative. And the way that we show that, well, it's clearly by the negative sign. But they both have the same speed. We see that? It's 25 meters per second, but one's going to the left, one's going to the right. Typically, we use the negative when we say we're going towards the origin, and positive when we say we're going away from the origin. So we're going to look into some examples about that, but just know that velocity includes direction, speed does not. Speed cannot be negative, all right? Speed is the rate of change. Velocity is the rate of change, but includes direction, okay? Let's take a look. You might remember for our lab that we have a displacement time graph, and all that is saying is how far is the object from the origin at that point in time. So, for example, let's say that this is, whoops, cannot Microsoft Paint. Let's say that that is 10 meters right there. Boom. Okay, so what is this graph telling us? Well, the object at every point in time, say like 1 second there, 5 seconds there, it's at the same spot. It's 10 meters away from where I started. It's 10 meters away right there, and it's 10 meters away at second 5. So what can we say about its motion? Well, it's staying in the same place, therefore it's not moving at all. Something that's not moving, what speed does it have? Well, it's got a speed of 0. So over here on the velocity time graph, velocity, remember, can be positive or negative, but if it's not moving at all, it's just 0. And 0 on this graph is the x-axis. And if we were to draw that, it would just be like that, because the speed of this object over here is 0, so the speed on this graph must also be 0. It represents the same object. Do we see that? Another way you can think about that is the slope of this graph, the slope of a displacement time graph is the velocity. And the slope of this graph is 0 because it's flat, therefore the velocity must be 0 at every point. Okay? Easy enough. Let's look at the next example. Here we got, it looks like an incline and then it tapers off. So remember, this is not a picture, all right? This is not a particle going up an incline and over to the right. This is showing how far away is the object from where it started. So we see, let me get my pen. Right here is the origin. And then right here, something's going on. And in between there, what's it doing? In between here, what can we say about the slope? Well, the slope is constant. It's not changing in steepness at all, so the velocity must be constant. It's going at a constant speed. We can also say that the velocity is positive because it's getting further away. So anytime you get further away from the origin, the velocity is positive. Anytime you're going back to where it started, your velocity is negative. The slope is positive because it's increasing. So we know that the object here is getting further away. It's at a positive constant velocity. So what would that look like on the graph, on the velocity time graph? Well, if it's positive and constant, it's got to be straight. So at every point over here in the first part, the speed is the same because the slope is the same steepness from this point to this point. So over here, it's got to match that. Let me draw the points on here so you can see. All right. Now, what happens after that point? Well, it's flat again, and remember from the previous one, flat means it's staying in the same spot. Well, If it's staying in the same spot, then its velocity or speed must be 0. So what does that look like on the graph over here? Typically we draw a dashed line down and then boom, over, because it goes back to 0 speed. So that makes sense. Over here we've got a constant positive velocity and then boom, it stops. That makes sense. Over here we've got a constant positive velocity and then boom, it stops. It goes down to 0. So that's what that would look like. Let's look at this third one. All right, it's a little different. It starts out the same as the one before. You got a positive constant velocity. You know it's constant because the slope isn't changing. You know it's positive because it's inclining. And then what happens here? Well, it's going back to the origin, right? Because it's going back to 0. Remember, this is displacement. The y-axis is displacement. So as it approaches the bottom of the y-axis, then it's going back to where it started. So the slope over here on the left side is positive. The slope over here on the right side is negative. And what can we say about the speed of both of them? Well, it's constant because the slope is not changing between each point. Those are the 3 points. So what that looks like on the velocity graph is, well, you start out with a constant positive velocity again, and then dash, 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 dash. It immediately becomes negative because you're going back to where you started. Remember, that's what this is. You're going back to where you started. And it's constant as well, so that means it's going to be a flat line. So you go from positive constant velocity immediately to a negative constant velocity. And that dashed line just shows you that happened immediately, okay? That's all that means. And then finally we got one more. This is from the cart lab that we did in class on Tuesday. You may remember pushing the cart up the ramp, you got this displacement time graph. Well, what's this saying? All right. Well, over here, what can we say about the slope? It's pretty steep, right? Which means it's probably got some speed. Well, that makes sense because when we pushed the cart up the ramp, initially it had a lot of speed. And then what do objects do when they go up a ramp? If you roll a ball up a hill, what's it going to do? It's going to stop. Well, that's what we see here is the slope is getting less steep and less steep until finally, what happens at the top here? Whoops. At the top, what is the slope? It's flat. You see that? At the top of this graph, the slope is flat, so what can we say about the velocity? Well, the velocity must be 0. All right, well, what does that look like on the velocity time graph? Well, let's just mark that one point. The middle, we know that it has to cross the middle at some point because the velocity is 0 in the middle of the displacement time graph, so the velocity must be 0 here. Well, let's fill in what the rest looks like. What's happening to the speed over here? Well, we said it was steep to begin and then it tapers off, which means our velocity must start, you know, as high and then it slows down. So what does that look like? Over here, if we were to draw it, it makes sense because our velocity starts high and slows down, okay? And then how does it finish? Well, it's starting to speed up, but it's speeding up in what? It's speeding up in the negative direction. It's starting to go back. It's starting to roll back to where it started. That's why this line is going back to 0, but it's getting steeper and steeper and steeper and steeper and steeper, which means it's speeding up, but it's speeding up in the negative direction. So what would that look like over here? It's just going to continue on. And that makes sense because it's speeding up. The velocity is greater and greater and greater, but this time it's in the negative direction. So it crosses the x-axis because that's where velocity is 0 right here. And that makes sense because in the middle over here, the velocity is 0. That's where it stops. When you push the car up the ramp, it's going to stop for a split second, a very tiny moment in time, and then start rolling back down. So if you're able to take a displacement time graph and understand what would the velocity time graph look like, you're going to be very good on the test. So here's a view of each of them. And you'll be golden. So I guess there's only one thing left to say, and well, I brought my buddy here to tell you as well.
Physics rules!